aralarında en akıllı olan.
This one's the smallest. Her mum survived the quake.
Bu aralarında en minnoş.
On February 6, 2023, massive earthquakes devastated southeastern Turkey's Hatay province.
Hat man dich gerettet?
Did someone rescue you? 2 brown cats, 2 ginger.
Ne?
For many people, help arrived too late. The disaster claimed more than 50,000 lives. My name is Nisan Arikan. I live in Germany with my daughter and partner and work as an actress. But I was born here, in Istanbul. The city of my childhood will always be the place I call home. But that home is in grave danger. It's threatened by the same fate which devastated cities in Hatay. A major earthquake disaster could strike Istanbul any day.
Hello. Hello.
I'm in Istanbul visiting my best friend Patricia. She lost both her uncle and her aunt in Hatay.
Çok şaşırdı. Ben kendi deneyimimi anlatayım.
Here's what happened. I woke up in the morning. A friend had stayed the night and told me there was an earthquake in Hatay.
Then she got a message from her cousin in their WhatsApp group. It said, I just escaped from the rubble. My parents are still buried. I hear my mother screaming. We can't get out. Barış's relatives live in Antakya, one of the cities worst ravaged by the quake. At 4:17 a.m. local time on February 6th, a 7.8 magnitude earthquake struck the region. Like many, her cousins immediately ran out into the street to help others. But then another powerful tremor struck at 4:28 a.m. Their parents were buried below debris. The siblings were powerless. Tons of concrete separated them from their parents. For 2 days, they heard their mother's desperate cries until her voice fell quiet. They had to endure the reality that as temperatures dropped to zero, their parents had frozen to death, pinned down by the rubble.
We're filled with grief. We're scared. We're worried. We're devastated. The fact that we're so powerless to do anything enrages us. We can't express our sorrow. No one can. It's easy to talk when you're here, but those of us who are here can't truly understand what happened there. That's why I'm ashamed to say I'm from Hatay and that I'm hurting. I'm ashamed to say that I lost my relatives because I had the privilege to be here.
Bana değdi geçti baktığında.
Patricia and I have known each other since we were children. Back then, we lived and played here in Kadıköy, a district of Istanbul. This is our childhood playground. When the 1999 earthquake hit, we camped here with our neighbors. That was in summer on the 17th of August 1999. A severe earthquake struck southeast of Istanbul, resulting in the deaths of nearly 20,000 people. Even though the epicenter of the earthquake was some 80 kilometers away from here, we felt the ground shake and our houses rattle. My mother woke me up and we ran outside. For the next few days, we camped here on this playground. Today, the danger of a big quake is ever present, and I'm increasingly concerned for my home city and its residents because of it. Istanbul is the largest city in Turkey. With an official population of about 16 million, it's bigger than either London or Paris, and it's estimated that the real number of residents is closer to 20 million. Turkey's difficult economic situation is driving more people out of the countryside and into the city. Istanbul is the economic heart of the country. An earthquake here matching the magnitude of the one that struck southeastern Turkey would spell disaster for the whole country. Amid the hustle and bustle of everyday life, you might think it's easy to lose sight of the danger. But that's not actually the case. Many people here are deeply afraid. I talked to Hussein, the owner of a souvenir shop. He was a volunteer in Hatay in the earthquake zone.
It's of course a difficult time. All of us are preparing for a major earthquake in Istanbul. We're expecting it. I have a camper van in front of my house because of it, and I'm trying to spend more time outside in nature.
Many people feel the way Hussein does. They live under constant threat. This modern, vibrant city is in danger. So how imminent is an earthquake disaster? And what consequences would it have for Istanbul and its residents? In a cafe on the outskirts of Istanbul, I meet with one of Turkey's most well-known geologists, Professor Naci Görür. For years, the scientist has been sounding the alarm about impending earthquakes, including the one that struck southeastern Turkey.
When there was a small quake on February 3rd in the southeast in Osmaniye, the media asked me about it and I said, forget about Osmaniye, look at Maraş. I'm concerned about Maraş. That was 3 days before the huge quake on February 6th in Hatay.
He considered it inevitable that a massive quake would strike the Hatay region in southwestern Turkey. It's difficult to even conceive of what a quake of this magnitude would do to Istanbul. But just like the Hatay province, Istanbul sits atop tectonically active ground, meaning it's prone to earthquakes.
Şimdi Türkiye en aktif bölgelerin başında geliyor.
Turkey is one of the most tectonically active areas on this planet. That's why so many earthquakes occur in our country. It's due to the natural movements of the tectonic plates in our region.
Doğal faaliyetleri. Yani biz buna depremlerin migrasyonu.
Turkey lies on the Anatolian Plate. To the north is the Eurasian Plate. The Arabian Plate pushes from the south, moving the Anatolian Plate westward. These active plate boundaries are called faults. The fault in the north funnels most of its energy from east to west. That's why there's been so many magnitude 7 earthquakes throughout the 20th century, moving west towards Istanbul. And that's why the Marmara Sea off Istanbul will be the site of the next earthquake.
Yeni bir deprem için hedef haline geldi.
To geologist Naci Görür and many other experts, it's perfectly clear Istanbul and its millions of residents are facing a deadly disaster. A mega earthquake could strike at any time, and the likelihood of it happening increases with each passing year. Is there anything that Istanbul and its people can do? Or are they simply at the mercy of nature? I meet with a Spanish scientist who is investigating this very question, seismologist Patricia Martinez-Garzon. She's based at the German Research Center for Geosciences, GFZ in Potsdam. With her project Quake Hunter, she's tackling how to better detect signs of earthquakes before they hit.
I think at the moment it's not possible. This is one of the most challenging questions in seismology, and with the development of new methods like artificial intelligence, new processing techniques, what it is called the big data, so that we are able to process efficiently vast amounts of data at the same time. give us a new hope that it is worth to revisit new cases and still look for new types of signals that maybe before were not identified.
Patricia Martinez-Garzon is searching for previously undetected patterns in seismic recordings. I accompany her to the tiny island of Sivriada to find out more. Around Istanbul, the Turkish Disaster and Emergency Management Authority AFAD and the GFZ have built out a network of seismic stations. On Sivriada, we meet Felice Tuba Cadriolo from AFAD. Here, at a depth of 300 meters, a geophone records the tiniest movements of the Earth's crust.
This is it.
Yes.
And here we have basically 3 data loggers, which basically receive the data that is coming from the instruments and convert it to digital. And then we transmit the data with this modem that has internet. We transmit it in almost real time to our colleagues, AFAD, the Turkish Disaster Management Presidency in Ankara. And from there, they send it to us almost in real time to the GFZ Potsdam.
If the epicenter of a major earthquake were to be located near the seismic station, Istanbul could be warned ahead of the first waves. Then there'd be 5 seconds to secure critical infrastructure, closing bridges, shutting down power plants, switching traffic lights to red and halting trains. But 5 seconds is not nearly enough time for the people who are inside buildings to get to safety. If a warning could be given earlier, it could save thousands of lives. Here, off the coast of Istanbul, energy is building up, as Patricia Martinez-Garzon explains.
And with our research, we try to determine whether the fault is locked and it hosts a higher potential for a very large earthquake of magnitude 7 or more, or the fault is creeping, and that will mean that the 2 sides of the fault are slightly sliding and not hosting that much energy, and therefore their earthquake potential is a bit smaller.
So the extent of the danger Istanbul is facing depends on the behavior of the fault in the Marmara Sea. Is the fault creeping or is it locked? And can scientists determine the answer using seismic technology? Patricia Martinez-Garzon and her colleagues are investigating these questions some 200 kilometers east of Istanbul. Izmit Pasha in northern Turkey also lies on the North Anatolian Fault zone, but here it's been proven that the tectonic plates are creeping. It's the end of March. At an altitude of 1,200 meters, it's cold, from -5 to -10 degrees Celsius. But the seismic stations set up by AFAD and GFZ still need to be maintained. The geoscientists have to swap out the batteries and storage devices 2 to 3 times a year. This time it's the GFZ's turn. Aside from routine maintenance, the team checks whether the station is detecting seismic signals and recording them correctly. The measuring devices function independently of the power grid. This ensures they can record the Earth's movements all year long, without interruption. The seismic stations are installed along the North Anatolian Fault. Sometimes they can be found near a cemetery, protected in a community hall, or, as is the case here, located in the back shed of a mosque with the permission of local officials. The less than ideal weather conditions have delayed the team from the German Research Center for Geosciences. Patricia and her colleagues were hoping the weather would be milder now that it's spring. After months away, they're anxious to find out if the station is still operational.
Yeah, so...
Is it working?
Yeah,
it is working.
Looks like.
I'm glad. Yes.
We have a big spike, which might be... Okay, so we will see. Okay, so here we have a seismic station on the back part of a mosque. This is a very narrow room in which it is protected, and the data is being collected there. There is the instrument, and the data is sent inside this box where we have the data logger, where we convert it from analog to digital, as well as the batteries. And now we have connected the computer where we can visualize the data that is coming in and collect the data from the previous months. Ping, you see? Now here you have an earthquake.
The region near İzmit Pasha is one of a few places on Earth where tectonic plates are creeping past each other. Scientists want to measure this movement as precisely as possible. That's why they're installing GPS-supported tracking devices on both sides of the fault, which can register even the smallest of movements.
Ocean bottom. Yeah.
And when you look at the rocks here, you see the green. These green rocks are serpentines, which facilitates the slow motion, the creep.
Amazing.
Yeah.
So is it the rocks that make the fault slow?
Yeah, these green rocks are serpentines. Serpentines in Latin means snake or something. Yeah.
Serpiente.
Yeah.
Sí. Yes.
These rocks have very low friction, so the fault
is continuously moving.
Yes.
Researchers know that creeping plate movement impacts the risk of an earthquake, but they don't yet know exactly how. Understanding more could help better assess Istanbul's earthquake risk. That's why this research is so crucial. Patricia Martinez-Garzon and her colleagues want to be able to identify the seismic signature of a creeping fault. Then they can better evaluate the fault near Istanbul. This was the spot where it was discovered that the tectonic plates were creeping past each other. This wall was built in the 1950s. Every year, the movement of tectonic plates results in one half of the wall moving about 2 centimeters to the side.
Okay, so here it's more.
So this is the amount of displacement since 1951.
By now, it's been displaced by about a meter. This wall may seem somewhat unremarkable, but in terms of earthquake research, it was a very special find.
This type of fault creep occurs in very special, very unique places in the world. And in particular, where we are here, the İzmit Pasha segment of the North Anatolian Fault is one of the best places to monitor this type of behavior.
We frequently visit this like a temple.
Yes.
For earth sciences here, dealing with creep and active tectonics. This creep here was discovered in 1969, about 9 years after the first discovery of this phenomena along the Nisan Arikan fault.
Yes.
You're still kind of in Europe.
Yes.
This is the Eurasian side.
Yes.
So this is the plate boundary, in fact.
Yes.
You see?
So we are standing right on top of the boundary.
The boundary,
the
yes.
plate boundary.
The boundary between, to the north, the Eurasian plate, and here, the Asian and Anatolian plate.
Wow.
Okay. Normally, as you say, the faults are locked due to friction and accumulate this strain and release during earthquakes.
What are you doing? This is the fault. So are we basically standing on the width of the damage zone?
Patricia Martinez-Garzon and Ziadin Chakir are standing right on the fault line. Here, the Earth's Anatolian and Eurasian plates have been moving past each other for 8 to 12 million years. In İzmit Pasha, this movement is happening relatively continuously. But further to the west towards Istanbul, it's a different story. There are many signs that the tectonic plates are locked south of the city. More and more energy is building up here year after year. History indicates that this energy is released at intervals of about 250 years. The last major earthquakes in Istanbul were in 1509 and 1766. So by that math, another big earthquake is actually overdue. Scientists in Germany are investigating just how great the threat to the city is. I visit the GFZ in Potsdam, the institute where Patricia Martinez-Garzon works. This is where earthquake research is happening at the highest level. It's here that I learn just how dynamic planet Earth is below its surface. The Earth's crust is constantly in motion. In many places, the continents are being pushed further and further apart. Liquid magma is continuously rising from the Earth's interior, pushing existing crust to the side. In some areas, for example on South America's west coast, these processes are also happening in the opposite direction. There, the oceanic crust and the continental crust actually push against each other. The Earth's crust is broken up like puzzle pieces into many different plates. At the plate boundaries, the rocks rub against each other, interlock, and detach again. The GFZ's experimental rock deformation laboratory is led by Eric Rebacki. The geophysicist and his team use high-pressure presses to recreate Earth's natural processes.
Wir gehen jetzt mal in diese Presse rein. Dann nehmen wir mal so ein hartes
We're moving to the press now. We'll take a hard rock like this and put it inside the press. And then we'll load it axially until it breaks. So now we'll go over here. I'll open the glass pane for you. And if you could please place the stone in between these two stamps.
Zwischen diese beiden Stempel.
Eric Rebacki wants to show me how hard rock behaves in a fault zone. His colleague slowly increases the pressure of the press until it reaches 18 tons.
Viel Kleinkram.
Lots of tiny pieces. The sample withstood very high stress levels. We were now at about 220 megapascals, which is a lot. That one was a very solid sample, and it fractured into a lot of little pieces. If you let such samples slide past one another, like what happens deep down in a shear zone, then you produce a lot of small eroded pieces. That's called gouge. In the subsurface, they rub past each other, and you get jerking movements.
Molten rocks react totally differently to the movements of the Earth's crust. They behave more like this modeling clay. It seems like the earthquake researchers borrowed an idea or two from the playground. In the analog modeling lab, I'm helping geologist Nisan Arikan set up an experiment. It'll help me visualize movement on the North Anatolian Fault.
Yes. And for the last one.
In the model, the sand layers at the bottom are pushed to the left. In other words, westward, just like the Anatolian plate.
Yes. And take it down. We down scale it to a few centimeters to a meter scale in the lab. And also, if the geological process in nature takes thousands to millions of years, we down scale to the lab 2 minutes to hour. So we can understand the process behind the geological process. That's the idea behind that.
In this sandbox experiment, the Anatolian plate is represented on the right. The model reveals what's been happening on the North Anatolian Fault over the course of millions of years. Although the movement is only from side to side, the sand is rising and falling at the boundary between the two plates. It's possible this type of movement is what formed the Marmara Sea near Istanbul.
Because of the interaction between small segments of the faults, you can also see that some parts are subsiding, they're going down, and some parts are coming, they're uplifting. So it's not only horizontal displacement. You have also some parts that coming up, exactly, coming up, uplifting, and some parts going down, subsiding.
The model makes me acutely aware of how the plate movements will inevitably affect Turkey, because this movement is not going to stop. The Anatolian plate will continue to drift westward, generating tremendous power. As more and more pressure builds up near Istanbul, this impending threat is what drives scientists like Patricia Martinez-Garzon to keep gathering as much knowledge as possible. The seismologist seizes every opportunity to learn more about the tectonic processes. She wants to go to the earthquake zone in Hatay. The scientist travels from Istanbul eastwards towards Antakya, one of the cities most impacted by the earthquake in February. Along the road to the south, Turkish authorities have set up tent cities. People who could not leave the earthquake zone have been sheltering here. On the journey, Patricia Martinez-Garzon makes use of every spare moment, working on a paper about the dangers facing Istanbul. Her first stop is a field near Antakya. There, she's able to witness firsthand the brutal force an earthquake can unleash. Turkish journalist Nisan Arikan shows her an olive grove near the city.
Yeah, it's wow. Wow, look at these beautiful pieces of stone.
Following the quake, the Earth's floor opened here. The fissure now spans a length of several hundred meters.
This is possibly the beginning of a new valley here, right? We are assisting to the birth of a new valley.
Does this mean that there's going to be a continuation of this crack then?
It could be.
With further earthquakes, or is this like a natural incident that will slowly go even without earthquake? Or
even without earthquake.
Oh.
So landslides basically are everywhere where there is a mass of rock or debris sliding downhill. And if you were unfortunate to put the house in a sufficiently unstable slope, for sure. So I wouldn't be surprised if we see something like this. Perhaps not as spectacular as this, but something like this happening here.
You all right?
Yeah, for the time being. Yeah, should be good. Thank you.
All right. Hold on. I think you're doing...
Yeah, I think
you don't need...
more or less this part. But you see, all this is wet.
Yeah.
It's super wet.
Yeah, yeah.
So this looks like a very solid rock, but in fact, when we touch it, it just basically disintegrates. It's a very soft rock that breaks very easily, and that it is also wet. This means that maybe water was flowing through here, and perhaps the rock is really not as hard as it was, as we thought it was.
It's not clear what exactly happened here. It's possible there was a large cavity beneath the olive grove. As a result of the quake, the waterlogged rock ceiling may have slid several meters to the side, then collapsed. In Antakya, professional fascination meets personal horror for the scientist. The quake almost completely destroyed the city. Many houses crumbled, becoming deadly traps for their residents. The bitter truth is, it's the collapsed buildings that kill people, not the quake itself. Antakya was famous for its beautiful, vibrant old city.
This whole old town is destroyed. For example, this used to be the alley of a mosque. Okay, these buildings might be inevitably lost, but now we wouldn't be facing the question, or is the soul of the city going to return?
And also we have seen on the way here that several of these buildings that still stand, they are deserted. There's no one living in them. And therefore the question is, of course, many of them died as the consequence of the earthquake, but those that survived, they likely left somewhere else. And will these families be willing to return here and start their life here again? Or is this city somehow condemned to remain lonely and cursed to some extent for a long time? Dice mi amigo.
you can't help but think, what if more buildings had withstood the quake, or residents had been warned to get out in time? How was Hatay?
So, yeah, it's beyond words, I think. And then you see all these families living in tents. There are tents everywhere. Every space that is free, it's filled with tents. And you see the kids outside playing. They have put some sliders and things like that, at least in some of them, so that they can be around and having a good time. But you don't even know if these kids have families alive.
Are the people of Istanbul destined for the same fate? After the 1999 earthquake, building regulations were tightened in Turkey. So in theory, houses built after that time should be earthquake-proof. But as the disaster in Hatay shows, builders there didn't adhere to the new regulations. And urban planner Akif Burak Atlar says the same holds true for Istanbul.
Fakat buna paralel olarak İstanbul'daki yapılaşmanın
We know that half of all construction work in Istanbul is mostly unregulated and unsupervised. It's very likely that building codes are not being followed here, which means, despite the regulations, Istanbul will most likely be in a very bad position should an earthquake strike.
Aside from the poor management of new construction, there are tens of thousands of residential buildings that were built before 1999. Buildings that will collapse like houses of cards in an earthquake, just like what happened in Antakya. Every house that crumbles traps people underneath, hundreds and thousands of families, neighbors, and friends. But every house that remains standing can spare lives. So how can we make buildings safer? This question leads me to the country in Western Europe with the highest incidence of earthquakes, Italy. At the University of Pavia, I visit the research foundation Oicentre. One of its founders, Gian Michele Carvi, says Oicentre aims to reduce the risk earthquakes pose to humans. To do this, the researchers test buildings in their original size.
You see the red light there because some test is going on, which means that we have somewhere oil at high pressure. So we have to be careful where we go because it happens sometimes that, you know, pipes break and it could be dangerous. But anyway, here we have...
Right now it's not safe for us?
Here it's safe.
The scientist proudly shows off one of the world's largest earthquake simulators.
We can have 5,000 tons applied vertically, dynamically. We can control the vertical load and displacement, the two rotation, and we can move in the horizontal direction whatever is inside there.
The tests clearly show rigid buildings with structural components that break easily or aren't well connected do not stand a chance. This is exactly how many houses in Turkey are built. The floors aren't well attached to one another.
Oh, yeah.
So it has been tested. You see that there is an actuator there that could move this in this direction, and there is an actuator there that could push and pull in this direction. So this is like part of a building.
Researchers collect lots of data throughout their experiments to learn more about the risk of collapsing buildings. In these tests, the size of the models is crucial.
We need to do a lot of real testing to understand the response of structures, essentially. Even if today we have a good capacity of numerical analysis, we are continuously discovering that to improve or to have good and reliable numerical models, we need to feed them with good testing. And testing cannot be scaled to small specimens and so on. We should be as close as possible to real velocity, real size, real elements to get good data.
Not far from Pavia in Milan, I get the opportunity to conduct an earthquake experiment myself. At the startup ISAC, Stefano Ci and his colleagues are developing shock absorbers. that make buildings more earthquake resistant. He shows me how the system works. The sensor in my hands controls a plate. In an earthquake, these plates move too, dampening the building's vibrations. In our experiment, the shock absorbers are mounted on the roof of the structure. The vibrations simulate an earthquake. The shock absorber should reduce the movement of the shelf. Without the shock absorber, the liquid easily sloshes over the rim of the glass.
Okay, now we will see the effect of the earthquake on these objects.
When the shock absorber is activated, the liquid remains almost entirely in the glass. Isaac's shock absorbers perform even better on the earthquake simulator in Pavia. The building on the right, with the shock absorbers installed on the roof, is barely damaged. Theoretically, the roofs of any existing structure could be retrofitted with this shock absorber system. In Gifoni, near Naples, the first Isaac shock absorbers are in use. A 5-story apartment building was equipped with them after renovation. With this technology, existing structures could become more earthquake resistant. So could the Isaac shock absorbers also protect older buildings in Istanbul?
So if an earthquake happens there, 40% of the buildings could be damaged. And I was wondering if a technology like this could save it just for a while before they repair everything.
The technology is non-invasive. It is easy to be installed on an existing building because it's composed by light materials that are mounted, assembled directly on the construction site. So you can imagine that it is not required to enter in the structure in a massive way, but you are not invasive at all.
The shock absorbers could at least buy residents a little time to get to safety. Of course, installing them would be an enormous undertaking, but it could save countless lives. Right now, though, there are no plans for anything like this. As we speak, tens of thousands of buildings in Istanbul are anything but earthquake-proof. That leaves hundreds of thousands of people defenseless against a quake. That's why Istanbul is trying to demolish thousands of unsafe buildings and replace them with new earthquake-resistant structures. Journalist Nisan Arikan tells me the transition is well underway. You're telling me there are 7,000 active construction sites every month? That's unbelievable.
Yes, as soon as a construction company is done with one site, they start on the next one. Every month, there are 7,000 construction sites in this part of the city. Construction is never ending. Eventually, they'll come here, and these 3 small buildings will be torn down and replaced with a big building. It's good business for these people. But it's basically supported by the government and the community because these buildings are not safe in an earthquake. And the new ones are supposed to be earthquake safe. That's the goal.
So it sounds like Istanbul will always be under construction. Will this construction boom really help in the event of a disaster? Or do these new construction projects actually create new problems? That's what urban planner Akif Burak Atlar fears.
The construction sector has been left to the market, namely the economic interests of clients and customers. We're seeing the effect of that play out now. In the last 20 to 25 years, more and more public spaces have disappeared. In other words, open spaces to which people could have fled in the event of a disaster. That land has been used for large construction projects instead of being developed into parks or other outdoor areas.
Experts calculate that in the event of an earthquake, there would be less than 1 square meter of open space per resident. So where could people go if their houses were destroyed after a big quake? In comparison, the playground where my neighbors and I took refuge during the 1999 earthquake feels almost like a luxury resort. My friend Barish tells me that people in Hatay say, it's not the dead who suffer from an earthquake, it's the survivors. They're the ones who watch their friends and relatives die. They're the ones who watch and wait as help fails to arrive, or arrives too late. What will people say when a major earthquake strikes Istanbul? We meet a resident in front of our old apartment building. All of these buildings will be demolished in 2-3 months. She can speak German because she used to live in Germany. The buildings will be torn down because they're not earthquake safe. The woman doesn't know yet where she'll live. It wasn't so long ago that I knew very little about the danger earthquakes posed to the city where I was born and raised. Patricia Martinez-Garzon and the other scientists have shown me that they are working on ways to help withstand disaster, but it may already be too late to protect the people of Istanbul. I am very worried. If the big quake comes, what will remain of my beloved city?